Hi, and welcome to Computer-Aided Drafting for Theater. You may notice that this looks suspiciously like a piece of paper and a pencil, not a computer. That's because we're going to be spending the first 3 weeks of the class working with paper and pencil before transitioning to Vectorworks, the computer-aided drafting software, in week 4. So you'll want to be sure to get your Vectorworks up and running by week 4 and to have your graph paper and scale rule as soon as possible because this project will be due next week. I'll explain in a few moments why we're working with paper and pencil first, but before I do that, I'm going to say a few words about these videos themselves. I'll start by saying this is Bert Scott speaking. I'll be team teaching the course with Rob Seiler. I'll be teaching the paper and pencil portion. Then Rob will introduce you to Vectorworks, the software program. Then I'll come back and walk you through projects using Vectorworks to draw the standard theater drawings of ground plans, sections, and elevations. And then I'll hand you back to Rob, who will finish off the course with sound and lighting drawings using Vectorworks. There will be a video every week corresponding to a project that's due the following week. Generally, the videos will be step-by-step walkthroughs of using either the paper and the pencil or Vectorworks to create a project. Occasionally, there will also be some lecture material at the beginning of the videos, but the videos will generally be step-by-step tutorials. The first several of them are going to be very short. Don't let that lull you into a false sense of security. They will get more complicated and longer as the semester goes on, but the first couple with paper and pencil will sort of ease us into the class. So why are we starting with paper and pencil? When you're working with computer-aided drafting, you always have to keep in mind that the final output is generally a printed piece of paper. So we like to start with that paper for a couple of reasons, but one, so you can sort of keep it in mind as you are creating your computer drawings, but also because sometimes it's easy to lose the sense of scale in the virtual world where you don't have any relative objects to compare to. So using physical objects, the paper and the pencil to start with, I've found helps people understand scale better, and scale is one of the main principles of drawing or drafting for the theater. So what is scale? Scale has sort of two meanings generally in the design world. And the first meaning is the relative size of one thing to another. For instance, if I were to show you this object and ask you how large it is, many of you will recognize it as the 3-inch cube from the Design Basics class, and you'll say it's 3 inches. However, if I told you that this is, in fact, a model of a stage cube that's a platform, then to ask you how large it is, now you're not so sure. It's certainly not going to be 3 inches. It's going to be larger than that, but how large is it? One way that you can get a sense of the scale is to introduce another object that has a size that you may be familiar with. For instance, if I add a person standing on top of the cube, now we get a much better sense of what size this model cube represents. If this is representing an actual person, then this cube is perhaps somewhere around 12 feet square. And I get that because if this is a 6-foot tall person, and even though not everyone is 6 feet tall, for drafting purposes, we just sort of assume that scale people are 6 feet tall because it's a nice round number. It's easier than 5'8". If this is a 6-foot tall person, you can see that basically two of this person could stand on top of each other. So that would be 12 feet. Let's put it back. So this is scale, the relative size of one thing to another. And scale is changeable. For instance, if I were to remove the person and instead put a puppy on top of the cube, now the relative scale of the cube changes. If this is a normal size puppy, it's probably somewhere from 1 foot to 1.5 feet tall, meaning that this cube is now probably only 1 foot to 1.5 feet tall. So the scale has changed based on the relative sizes of the two objects. If we were to introduce all three objects back, then we end up with a bit of a conundrum. Now what size is the cube? Well, there are two or more possible answers. One answer is that this is a normal sized person, or an average sized person, standing on a 12-foot cube, and beside him is a very large styrofoam dog. That's 12 feet tall. The other option is that this is a real dog standing on a 12 to 18 inch tall cube with a scale model person standing beside him. There may be other options, but those are the two that immediately come to my mind. It's not clear, and the only way to really make it clear is to label it somehow. And that's what leads us to the other meaning of scale, which is using mathematical proportion to represent one thing with another thing. And that's usually representing a large thing with a smaller thing. Here's a drawing representing our 12-foot cube in scale, meaning I've chosen a smaller object, each square of the graph paper, to represent a larger object, a 12-inch square. So this small square represents a 12-inch square, and there are 12 of these. So that means that there are 12 1-foot squares, meaning that this is 12 feet. So we've used a smaller object to represent a larger object. These squares happen to be 1/4 inch square. 1/4 inch. So each 1/4 inch represents 1 foot. So this scale is 1/4 inch equals 1 foot, which is a common scale that we use in theater draftings. So just to recap, with 1/4 inch graph paper, each square is a 1/4 inch. So in 1/4 inch scale, each square represents 12 inches, which I just showed you. Or if you wanted to make a larger drawing, if we wanted to make a drawing twice this size, we could use 1/2 inch scale, where each square represents 6 inches, or it takes 2 squares to represent 12 inches, and so on. In 1 inch scale, each square represents 3 inches, so it takes 4 squares to represent 12 inches. Generally speaking, the larger the object you're drawing, the smaller the scale needs to be in order to make it fit on the page, or the more detail you can add. So here is a 4 foot by 8 foot piece of plywood, represented in 1/4 inch scale, 8 feet by 4 feet, and it's this size. If we represent it in 1/2 inch scale, it's larger, it's twice the size. Or if we represent it in 1 inch scale, it's much larger. You might ask, why would you need different scales? Well, it depends on what's on this plywood. If I'm just representing the plywood, this may be fine. If I have some sort of construction detail, I need to show you where the legs are, or if you're building a platform or some other detail, it may be easier to draw it and to read it if I make it large. And if we're cutting out some intricate shape from this plywood, I may need to draw it even larger in order to represent that shape accurately. So the scale really depends on what you're trying to achieve with your drawing. The reason we're working with 1/4 inch graph paper is because this grid makes it relatively easy to visualize and work in two of the common scales that we use in theater and entertainment drafting, which are 1/4 inch scale and 1/2 inch scale. That's because if we have 1/4 inch squares and we're working in 1/4 inch scale, it's easy to see that if each square represents a feet of a foot. If each square represents a foot, then it's very easy to tell that this is 4 feet, this is 8 feet, this is 12 feet. Or if in half-inch scale, it's easy to tell that 1, 2, this is 1 foot, 2 foot, 3 foot, 4 foot, etc. I should say that what we're talking about in these first couple of weeks is not really hand drafting. Hand drafting requires lots of tools that we're not asking you to use. T-squares and triangles and all sorts of things. We're not really teaching that class. We're just sort of introducing computer drafting with hand drafting. So that's why we're doing it on graph paper, so that you can draw straight lines easily because you have a grid to work with. So I should point that out. It becomes a bit harder using the graph paper, or really any paper, when you're drawing in scales other than 1/4 inch or 1/2 inch, or if you're not doing even increments of things. For instance, if I needed to draw something in 1/4 inch scale that were 4 feet 6 inches, 1, 2, 3, 4, then what do so I have to sort of guess, or I can measure 1/8 of an inch. But if I start here and go 1, 2, 3, 4, 1/2 an inch, I can use a ruler to determine 1/2 of a quarter is a 1/16. I made a pretty good guess. So that's a line that's 4 feet 6 inches long. But what if I have a line that's 4 feet 2 inches long? That's where the scale rule comes in. The scale rule has on one side a regular ruler, which is what I was just using, but on all the other sides it is marked in scales. So this, for instance, the 1/4 inch, here's the 1/4 inch. Even though this distance is a 1/4 inch and this distance is a 1/4 inch, it's marked as 1 foot, 2 feet, 3 feet, 4 feet, 5 feet, 6 feet. So you don't have to count. If you want to draw 4 feet, you can just put this down and look at it and very easily draw 4 feet. Or if I need to draw 4 feet 6, on all of the scales there's a 0, and going in this direction is feet, and going in this direction is inches. So 4 feet 6 inches, you can see that 6 inches there comes to there. It might actually be easier to do this in 1/2 inch scale. So I'll find the 1/2 inch scale, and now 4 feet 6 inches. It's also much easier to determine odd sizes, such as 4 feet 3 inches, or 4 feet 1 inch, or whatever. So using the scale rule allows you to much more quickly do the drawings and more accurately, rather than counting squares and trying to divide them. But the squares help you line things up. The scale rule also lets you work in other scales, because we don't always work in 1/4 inch scale or 1/2 inch scale. Sometimes we work in an 1/8 inch scale, or 3/32 and 3/16 are not super common. 1/8, 1/4, 1/2 are sort of the common ones. We can talk about some of the others. And you may notice that these have, all of them except the 16, which is just the regular ruler, have scales that are going in both directions. So 3/16 inch scale starts this way and goes that way. So 0, 2, 4, 6, 8, 10. 3/32, which is half as big as 3/16, goes in that direction. So 0, 4, 8, 12, 0, 4, 8, 12. You can see that this one is twice as big as that one. So if you're wondering why these numbers, all of them work that way. This scale goes in this direction, and this scale goes in that direction, but they all start with a 0, and they all have a foot split up into other increments. The larger the scale, the more increments there will be here. In 1/8 inch scale, you're getting it's every 2 inches, 2, 4, 6, 8, 10, 12. In 1/4 inch scale, you're getting every inch. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And this scale, you're getting halves of inches, it looks like. So the more room you have, the more detail it can show you. And that's the same thing on a drawing. The larger the drawing is, the larger the scale is, the more detail you can include. Why would you need different scales? So here is a scale drawing of a bar from a show that we did in the Black Box a couple years ago. This bar is 5 feet wide and basically 3.5 feet tall. So this was a prop in the show. And it was drawn on an 11 by 17 inch piece of paper. and it's drawn in 1-inch scale. So 1 inch on this drawing represents 1 foot in reality. On the same size piece of paper, I can also represent the entire set. So this drawing is a ground plan that represents this set that was in the black box. You can see if I put the person in, the relative size of that set. So the bar would be about this size, about 5 feet wide and 3 feet tall. So it is much smaller, obviously, than the entire set. However, I can draw the entire set on the same size piece of paper by using a different scale. This is 3/8 inch scale. So the larger the thing that you're drawing, if you're using the same size piece of paper, the smaller the scale needs to be in order to make it fit. Here's an example of drawing the bar in the same scale that the set was drawn in. So our original drawing of the bar is in 1-inch scale, and this is how large it is. And our set itself was drawn in 3/8 inch scale. If I draw the bar in 3/8 inch scale, the drawing of it goes from being this big to being this big. This may be too small to get all the details in, which is why I chose a larger scale to draw the bar in. On the other hand, if we look at the drawing of the set, each one of these floor tiles is about 2.5 feet square, and you'll see that they all fit on this page in 3/8 inch scale. If I were to change and draw them in 1-inch scale, which is the same scale that the bar was originally drawn in, then instead of being this size, they're this size. And you can see very easily that the whole set would not fit on the page if I were drawing it this size. So when you're thinking about scale, part of what you're thinking about is how it will fit on the page. And the other thing you're thinking about is how large does it need to be in order for me to show the appropriate amount of detail. Speaking of paper and the size of drawings, let me take just a brief detour into the sizes of paper that are commonly used in theater or architecture drafting. And those are letter size, which we're all familiar with. This is a letter size piece of paper. It's what we would call a standard size piece of paper. It's letter sized. The next size up is, and that's 8.5 by 11, tabloid or ledger, which is basically 2 8.5 by 11 pages placed next to each other. So this piece of graph paper is, in fact, 11 by 17. The next size up is Arch C, or Architecture C, which is 18 by 24. You can't see all of it, but the piece of paper that's under this drawing is 18 by 24. This is probably the largest size that we'll be using in class this semester. We may or may not be actually printing these things out. When I say size of paper, I may be referring to the PDF print size, but that's probably the largest size we'll be using for scenery. Lighting plots usually need larger paper, and the other larger sizes are Arch D, Architecture D, which is 24 by 36, or the really big one, which is Arch E, 36 by 48. So yes, that is in fact 3 feet by 4 feet. That's a very large piece of paper. But if you're drawing a 1/2-inch scale light plot for a large theater, it takes a large piece of paper for it to fit. So these are the common sizes of paper. They are all bigger than this piece of paper. Well, actually, these three are bigger than this piece of paper. So I have represented them in quarter scale, which is different than quarter-inch scale. Quarter scale means that they are a quarter of their real size, or 3 inches equals a foot. So that's the scale that they have been drawn in on this paper. All right. Now, hopefully, that wasn't too confusing, so I will introduce you to your first project. All right, here we have it, project number 1, which should be very simple. Using your 1/4-inch graph paper, I would like for you to draw 3 different things. I'd like for you to draw a 3-foot 6-inch square. I'd like for you to measure a space that you have access to, probably the space that you're working in when you're drafting, your room, your kitchen. If you're working in the library or the computer lab in a large space, just pick a space, any size space you want that you have access to measure. You should have gotten a tape measure for the class, so hopefully you have a tape measure. And I'm talking about the overall dimensions of the space here. We're going to do a detailed ground plan of the space in Project 3, so here I'm just looking for the overall dimensions, 12 feet by 14 feet, 10 feet by 10 feet, whatever the overall dimensions of the space are, with no interior details. And then the third thing is the typical theater playing space. So on a typical proscenium stage, the playing space is 40 feet wide by 30 feet deep. What's the trick, you ask? There really is no trick, but what you have to do is fit them all on the same page. So you need to use an appropriate scale to make them all fit, because logically, the 3-foot 6-inch square is going to have to be drawn in one scale, but if you draw the 40-foot room in the same scale, it's not going to fit on the paper, right? So probably these 3 things are each going to be drawn into different scale. 1/4-inch may work, 1/2-inch may work. You might need to go to a different scale. Please use the scale rule for this. Get used to using that, and label each one with its scale. So under each one, write scale and write what the scale is. You don't need to dimension it, because we haven't talked about how that works yet. But what you should end up with is 3 squares or rectangles that are laid out on the page to fit nicely, and are in a scale that is marked. You might want to sketch them out first. This may seem surprisingly easy. There's no trick here. I'm just trying to get you to recognize representing vastly different size things in the same space and different scales. So that's the project. 3 squares or rectangles, all drawn on the same piece of graph paper, each in an appropriate scale, each one labeled with the scale that you've used. All right. If you have any questions, you can contact me via email or text. My number is in web courses. I am in tech for the next, forever. So I'm not going to have regular office hours, but I am happy to, if you text me or email me, I'm happy to talk to you on the phone or set up a Zoom meeting with you to talk over things. So no regular office hours, but office hours available by appointment. Or often I can solve your problem over text. Okay, happy drafting.